Hi, Professor. My name is Chen Hao, and today I would like to talk about my project. And my project name is using Coastal Loop method to recover and check carrier of BPSK modulation signal. And I divided my presentation into 6 parts. And the first part is introduction, and the second part is problem and study. And next, I will talk about the existing approaches. And then is the description of the study approach. And the next one is performance evaluation. And the last one is the conclusion. Okay. So the first part is the introduction. Carrier synchronization, also known as carrier restoration, is a local oscillation in the receiving equipment, which is in the same frequency and phase as the carrier of the received signal, and supplies it to the demodulator for coherent decommissioning. If there is no discrete carrier component in the received signal, for example, in BPSK signal, the receiver needs to extract the carrier from the signal with more complex methods. Therefore, a carrier synchronization circuit is needed in these receiving devices to provide a coherent carrier for coherent demodulation. The coherent carrier must be strictly in the same frequency and phase with the carrier of the received signal. And that is the problem and study. The causes of carrier synchrony as follows. The first one is that any two independent oscillators are out of synchrony. And the second one is that even if the two independent oscillators used by the transmitter and the receiver are synchronized, the propagation of the electromagnetic waves in the channel will cause phase changes that are unknown to the receiver. So there are two methods of extracting carrier wave. One is that the pilot is not specially transmitted, but the carrier is directly extracted from the transmitted signal at the receiving end. This kind of method is called direct method, also known as self-synchronization method. And the other one is to insert one or more sine waves called pilot at the appropriate frequency position while transmitting UFO signals. The receiver uses the pilot to extract the carrier. This method is called insertion pilot method, also known as external synchronization method. And then I will describe my study approach. Coastal ring method. Coastal ring method is also called in-phase orthogonal loop method or edge ring method. Compared with the square loop method, it still uses the PLL to extract the carrier frequency, but it doesn't need to square the received signal to get the carrier frequency output. After the squared operation of carrier frequency, the working frequency of the later phase lock loop is doubled due to the frequency multiplication, which makes the implementation more difficult. Coastal loop replaces the square with a multiplier and a simpler low-pass filter, which is its main advantage. It has the same performance as the square loop method in theory. So the right picture is the coastal ring method figure. So in the figure, the received signal SD is here. Is fed into a two-way multiplier. This is two multiplier. The voltage control the oscillation voltages of point A and point B inputs by the two-phase multiplier are respectively in the following form. This is way A and way B. And when they are multiplied by the received signal voltage, the voltages at C and D are obtained in the following form. This is VC and VD. So after passing through the low-pass filter, these two voltages become the VE and VF. This is two low-pass filter, and VC and VD pass through a low-pass filter become VE and VF. So after multiplying the two voltages, the input voltage of narrowband filter at G point is returned in the following form. And VE and VF multiply up pass through multiplier and we got VG. Replace empty equal to 1 and narrow and negative 1 into equation 6, and consider that when phi minus theta is very small, so the sin phi minus theta is approximately equal to phi minus theta. So equation 7 becomes in the next form. So when phi is equal to theta, Vg is equal to 0, and Ve is equal to 1 second empty, the output voltage Va, the Va is here, of VCO is a carrier extracted by Costas loop, which can be used as a local carrier of coherent reception. Okay, so next I will talk about my performance evaluation. The Costas loop is composed of multiplier, loop filter, and voltage controller oscillator, which have good tracking, narrowband filtering, and memory performance. Compared with the square transform method and the common phase locking loop, it has better performance and its advantages to extract the carrier signal. The last part is the conclusion. So the Costas loop carrier synchronization simulation platform is built in the simulating environment, and the structure is as follows. And the whole process is that BPSK modulated signal is multiplied by the local oscillator signal generated by voltage controlled oscillators through AWGN channel, and the baseband signal is returned after low-pass filter. The structure of BPSK is as follows. And this is our input wave, and this is our baseband signal. And after we need to set up our pyramid first, and in this experiment, when the carrier frequency is 10,000 Hertz and the frequency offset is set to 10 Hertz, the cosine wave is as follows. And we set our frequency here. The signal to noise ratio of AWGN channel is 10 here. And then the local frequency of VCO is 10,000 Hertz, and the sensitivity of VCO is 100. This is our frequency and input sensitivity. And the other VCO signal is set as high second phase. This is initial phase. And then the sampling frequency of two low-pass filters is set to 100,000 Hertz, which satisfies the next sampling law, and the cutoff frequency 2200 Hertz. We set our Fs, Fpass, and Fstop here. The loop filter sample frequency is set to 100,000 Hertz, and the cutoff frequency is 1100 Hertz. This is frequency here. And then we got our signal waveform. And the signal V0 waveform of BPSK signal after passing through AWGN channel is as follows. And the same frequency and the same phase signal with V1 waveform produced by VCO as follows. And then we got our demodulated signal. Waveform comparing between the demodulated signal and the original baseband signal is as follows, and the upper is the demodulated signal V5, and the below is the original baseband signal. So the output signal of VCO is directly supplied to one multiplier, and the other is the output signal of VCO after 90-degree phase shift. The output of the two multipliers contains the modulated signal. The influence of the modulated signal can be eliminated by multiplying the two. The counter voltage only related to the phase difference between the VCO output and the ideal carrier is obtained by loop filter, so that the VCO can be adjusted accurately and the original carrier signal can be recovered. Okay, thanks for watching. And next I will show my program.